Okay, so in today's video, lecture we study that uh, if we have a problem with the minimization type, how we are going to solve that. There are different cases or situations in which there are different ways for using uh, of getting a solution of a NP problem. Right? Now, let's say that this game of C, we can use simplex method only for the objective function which are of maximization type. So, if the objective function is maximization, then only we are able to use the simplex algorithm. Right? But what happens if the objective function is of minimization? Then we need to make certain alterations. There are two ways of solving this minimization problem. One is by a method which is known as the two-phase method. Right? Now, in this two-phase method, what is done is basically we convert the minimization problem into maximization problem, and then we, you know, systematically remove the variables, and we add to the we get to a certain solution, optimized solution, right? And the second one is the big M or the penalty method. Right? Now, in this problem, in this case of when we use the big M method, what we do is we do not convert the objective function. We leave the objective function as same. If it is of minimization, we leave it for minimization. If it is for maximization, we leave it for maximization, right? And then we solve accordingly. Now, what happens is, since two-phase method is not in the syllabus of course, so we won't be discussing about the two-phase method. We'll be focusing on the begin method. Now, before we go ahead, there are certain conditions which are there, which you should know, right? There are certain cases in which we do not get the initial basic feasible solution. Okay? All of us know that in order to get an optimized answer for a linear programming problem, what we need is we need an initial basic feasible solution. So the initial basic feasible solution is one is z is equal to 0. And we have variables which are forming the identity matrix. So what happens when we are not able to form an identity matrix? So for example, let's say I write an equation. The constraint equation is 5x1 plus 2x2 is greater than or equal to 6, right? The second constraint equation is 3x1 plus 4x2 is greater than or equal to 8. Now, if I convert these constraint equations into inequalities into equations, so from the first equation, it is clear that we have 5x1 plus 2x2. And I need to subtract something from the left hand side. So subtract something which is known as minus s1 is equal to 6. And then I go to the second equation, I write 3x1 plus 4x2 plus s2 is equal to 8. Now, if I convert it into the matrix form, 5, 3, 2, 4, minus 1, 0, 0, 1. Now, this is not an identity matrix. This is not an identity matrix because here we have negative 1. It would have been 1, then we were fine with it. So, this is not. So what will happen is we need to add another variable over here, which is an artificial variable. So now, what will happen is we matrix change this to 5, 3, 2, 4, minus 1, 0, 1. Right? And then I have 0, 1. So this is my x1, this is my x2, this is my s1. Right? So now these two are forming the identity matrix. So in my initial table, these two will come in as the artificial variable and the s2, that is the slash variable. Right? They will enter into the table, which is for getting the initial basic feasible solution. Right? So the same is the case when we have an equation. We have an equation. In order to get an identity matrix, we have to add an artificial variable. So both the methods, whether it's a two-phase method or a bigger method, we have to add the uh, artificial variables where the constraint equation is of greater than equal to sign or an equation. So if the constraint equation is an equation, it has equal sign, still we have to add an artificial variable. And if we have greater than equal to sign, we have to subtract the surplus variable and then add the artificial variable. Right? So that is how it goes. Now let's come to the big M method. Big M method is also known as the penalty method. And what does the big M or penalty mean over here? Right. So when we talk about the big M method, there are two things which we need to keep into mind. Right. We have to see if our objective function is of maximization type or minimization type. In big M method, if the objective function is of maximization type, right, then we give a penalty which is given as minus m, where m is a very large number. Okay. So if the objective function is maximum thing, then we have minus m as penalty. And if it is of minimization type, then we give a penalty of plus m, right? Now I'll solve a question and according to that, I'll ask you one thing more. When we have maximization as minus m, then the value of Cj minus Zj, okay, that changes a bit. So I'll solve two questions, one of minimization and one of maximization, and it will clear both the doubts that we have, right? So now I'm starting off with a problem, and then we can understand in a better way how we have to go with the problem. So let's take the first problem as first question I'm taking of minimization type, right? So we have to use big M to solve the following LP problem, right? So see again, all the steps remain the same, but there is a slight change. So the way of iteration remains the same. We have to have a outgoing variable and an incoming variable. Then we need to select the key row, and the key element is to be made one, and all the corresponding elements of the column is to be made zero. So all the entire process remains same, but there is certain difference. So let's see what the difference is. Let's say we have minimize z is equal to 5x1 plus 3x2, right? And these are subjective to constraints 2x1 plus 4x2 less than equal to 12. Then 2x1 plus 2x2 is equal to 10. And then we have the third type, which is 5x1 plus 2x2 greater than equal to 10. So we have three constraint equations. And let's start with the uh, non-negative constraint equation. Let's do greater than equal to 0. So I'll be converting this into the standard form, and then I'll be creating the table, matrix and table, and then we can go ahead. So let's convert it into the standard form. So again, minimize z, it remains the same, 5x1 plus 3x2. So the first constraint equation is 2x1 plus 4x2 less than equal to, it's very correct. So we need to do what? We need to add a variable s1 to left hand side and to convert it into an equation. So I write 0 s1. Okay, perfect. So let's do second one. Second one is an equation. So in order to get an identity matrix, I'll have to add in a artificial variable. So I'm adding an artificial variable a1, right? So when I add a1 over here, right, What is required is, so I'll add over here. Because it's a minimized problem, so we need to add plus m. So m is the coefficient, m is the penalty, and a. Okay. So that is equal to 10. The third equation is 5x1 plus 2x2. So this is greater than equal to, we need to subtract something. We need to subtract a variable which is s2, right? That is converted into equation. Now we need to add an artificial variable as well to make an identity matrix. So in order to get an initial basis feasible solution, I have to add an artificial variable a2 over here. Okay. So what we have done is we have added 0s2 plus ma2. And now we have variables x1, x2, s1, s2, a1, a2, all having the non-negative constraint equation. That is the first thing. Now I'll create the table over here, the first table that we have, or I'll create both the things. I'll create table as well, and then we'll create the first we'll create the matrix, and then we'll create the table. Okay. That will clear the concept of it. So let's make the table first. So for table, let's see um, our matrix one. Okay. So we have two, then we have four, then we have S1, then we have S2, we have A1, and we have A2. I'm writing the variables over here in the matrix form. So we have X1, X2, S1, S2, A1, A2, and this is equal to 12, 10, 10. So this is the matrix form, right? AX is equal to B. Okay. Now I'll write this second one. So the second equation is 2, 2, and 0, 0. Then we have A1. Third one is 5, 2. Identity matrix, right? So I'll convert it into the table now. So if I write the table, the first is basic variable. First column is a basic variable, right? And second we have CB, and we have XB. We have all the variables X1, X2, S1, 2, A1, and A2. And we have a column of XB by XJ, minimum ratio, right? Now, see the first variable that forms the identity matrix is S1, then we have A1, and then we have 2. Okay? So these three variables are forming the identity. Right? Now I'll write Cj. I'll write the coefficients in the objective function. 5300. This m and this is n. So it's a minimized problem. So we have positive x, right? So let's write the CV. F1 is 0. This is n. This is m. XB is 12, 10, 10. And then we can copy the entire matrix from over. 1, 0, 0, 0, then 2, 2, 0, 0, 1, 0, and then we have 5, 2, 0, minus 1, 0, 1. Right? So Z and the first instant is 20m. Here we have 20m. So after that, we calculate ZJ. So we can see that 2m plus 5m, 7m. Then we have 4m, 0. Then we have minus m. Then we have plus m. We have plus m. Now we have Cj minus Zj. So we have 5 minus 7m. And we have, can put it number 3 minus 4m. Right? Then we have 0. Then we have plus m. And then we have 0 and 0. Right? Now, we know that if the value of Cj minus Zj is 0 or negative, then it's an optimal solution for a maximization problem. Now, here the things get reversed. If Cj minus Zj is all positive or 0, then we get an optimal solution for the minimization problem, right? So, for minimization problems, the condition of Cj minus Zj just reverses, right? So, and what do we choose? So 5 minus 7. Now, m, you remember that m is a penalty. It's a very, very, very large number. So obviously, this will be a more negative number, 7m. And here we have 4m. So say minus 7m, it's a larger number. So we'll select this. So incoming variable is s1. Now 12 by 2 will give me 6. This will give me 5. And this will give me 2. Right? So this is the leaving variable. This is the leaving variable. This is the key row. And now we need to make alterations. So the first variable remains s1. This is a1. And a2 is moved out. So once an artificial variable moves out, it will never enter the table again, right? So once the artificial variable moves out of the basic variable table, it cannot enter the table again, right? So we have to eliminate the corresponding column. So a2 is out, so we will just slide off for this so that we do not tabulate for this particular column. So no tabulation has to be made for this column, right? And instead of a2, we have x1. We have written this. Now see, x1 coefficient is 0, this is n, and a2 x1 is 5. See, now the key element is 5, so the transformation needs to be made. R3 tends to R3 divided by 5. So 10 divided by 5 is 2. 5 divided by 5 is 1. This is 2 by 5. This is 0. 1 by 5. And this is 0. And A2 is removed. We do not have A2 anymore. So would participate in the transformation. So, yeah. Let's come to the first row. The first row element is 2, and we have to make this 2 as 0 with respect to the third column or third row. Key row. Right? So the transformation is R1 tends to R1 minus 2R3. पहले इस 1 को 2 बनाएंगे और फिर इसको 0 करेंगे, ठीक है? So 12 minus 4 is 8. So I get an 8 over here. 0. 4 minus 4 by 5. ठीक है? ये आ जाएगा 16 by 5. And this will remain 1. This will remain, this is what? Minus 1 by 5, 2 by 5. This becomes 2 by 5. And last value remains 0. So that is the 0 that we have. Now, second one, again it is a 2. So again R2 tends to R2 minus 2 times R. So we have 10 and minus 4 will give me a 6. Then here I will get a 0. Over here we will get 2 minus 4 by 5, 6 by 5. Over here we get a 0. And over here again we get 2 by 5. Here we have 1. So that is what the tables looks like after the first iteration that we have. Now let's see how much is Z. Z is 6m plus 10. 10 plus 6m basically. So we have 10 plus 6m. That is the iteration. Now let's see Zj. See the value of Zj is we have 5 over here and we have 10, 5, 2, 2. So we have 6 and we have 5 plus 2. So 6m by 5 plus 2. Right? So this will remain 0 because both the values is 0. And then this is 1. So this is 2m by 5 minus 1. Okay. And this is m. Now let's see Cj minus Zj. Cj minus Zj. See 5 minus 5 is 0. 3 minus this. So this will be 3 minus 2. I'll get 1. So I'll get a 1 minus 6m by 5. This is the value. Over here we get a 0. And over here we get, will be plus. So 1 minus 2m by 5. So we still have the negative value. We have two negative values up now. So we will select again this minus 6m by 5 is more than 2m by 5. So this is 1 point something. This is 0.8 something. This is a smaller value. So this is the larger value. This is selected. Now let's see what will come. This is the entering variable and x2 will enter now, right? And something will move 40 by 16. So that is 5 by 2. So we get a value of 5 by 2 from here. Then we have 6 cancel 5. We have a value of 5. And here we have 2 to 5. Again, we have a value of 5. So, obviously 2.5 is lower value. We'll select this. Okay. So now the key element is 16 by 5. So we need to make this as 1 and then we need to subtract all the other. And just change the field. We're done with that. So let's go with the table again. Just basic variable. So now instead of S1, we will have X2, right? CV, XP, X1, X2, S1 and S2. Now because I won't write A1 because A1 is also moving out. No, we have A1 as of now. So XP by XJ, and then we have the equation. So the first basic variable now we have is X2, then we have A1, then we have X. So these three are into the table now. The coefficient of X2 is 3, right? A1 is M and X1 is 5. Now we have chosen the first, so we need to, that is 16.5, so we need to iterate it, we need to get 1 over there. So the process of doing that is R1 tends to R1 divided by 16 by 5. So we are dividing by or multiplying by 5 by 16. So the value that we had was 8. 8 multiplied by 5 by 16. That's 5 by 2. Right? We just calculated it 5 by 2. Then we had a 0 in the first place. So we get a 0 over here. Then 16 by 5 is to be made 1. So that is 1. The next value was 1. So that will be 5 by 16. Then we have S2. That is 2 by 5. 5 by 16. 1 by 8. And then we had a 0. So that is the first row. The second row, we have a value of 6 by 5. So R2 tends to R2 minus 6 by 5 of R1. Okay. ये करते हैं देखते हैं क्या वैल्यू आती है वैल्यू में 6 minus 6 by 5 और 5 by 2. Okay. ये वैल्यू आती है मेरी 3 0. Again this is to be made 0. इज क्या है, -3/8 बाय 4 क्या है 1। थर्ड वाले पे आते हैं, R3 टेंड्स टू 2/5 है, R3 -2/5 of R1. The first value was we had a 2 over here. So 2 minus 2/5 है 5/2, तो 2 minus 1 1 आ जाएगा, 1 आ गया। ये वैल्यू हमारी 1 थी तो ये 1 ही रहेगी, ये वैल्यू 0 हो जाएगी, ये वैल्यू -1/8 4 ये हो जाएगी। ठीक है, फाइन, वी आर डन विद दैट। नाउ लेट्स सी व्हाट द वैल्यू ऑफ z इज। z कितना आता है, ये हो गया 15/2 प्लस 5, तो 25/2 प्लस 3 है। z इज 3m प्लस 25/2। z से निकालते हैं, तो ये तो हो जाएगा 5, ये हो जाएगा 3, और ये हो जाएगा कितना, 3/3, 5/8 माइनस 3m/8, 16 हो गया यहाँ पे, 5/16 माइनस 3m/8 हो जाएगा 5/16 माइनस 3m/8, वैल्यू आ गई। सिमिलरली इससे आगे जो वैल्यू है ये हो जाएगी 3/8, 5/8, 5/4 माइनस 3m सॉरी m/4, m/4 माइनस 7/8 हो जाएगा m। ठीक है, cj माइनस zj करते हैं, 0 0 हो जाएगा 3m/8, 3m/8 माइनस 5/16। नॉट दिस इज अ पॉजिटिव वैल्यू, ये 3m पॉजिटिव आता है, तो ये पॉजिटिव है, सही है। यहाँ कितना आ जाएगा, तो हो जाएगा 7/8 माइनस m/4। देखो अगर ये वैल्यू हमारी पॉजिटिव आ जाएगी तो हम यहीं पे छोड़ देंगे, ये हो जाएगा 0। अब ये सेलेक्ट हो जाएगा, तो नेगेटिव में है, कहाँ जाते हैं, ये सेलेक्ट हो गया, यानी S2 विल एंटर टू समथिंग, ये तो नेगेटिव है जाएगा ही, ये दोनों बचे, तो 20 आ गया इसकी वैल्यू। ठीक है, 7/40, 40/2 20, और ये हो गया 12। तो ऑब्वियसली A1 will move out again, so A1 is moving out, that means we don't have to iterate for A1 anymore। Okay, so the value is x2, x2 का 3, A1 बाहर जा रहा है, ये हमारा ऐसा हो गया, ये एलिमेंट है 1/4, तो A1 की जगह आ रहा है S2, S2 is 0, and then we have x1, x1 का है 5। तो सेकेंड रो में करना है 1/4 को 1, तो R2 टेंड्स टू 4 से मल्टीप्लाई कर दीजिए, 4 R2। ठीक है, तो ये कितना हो गया, देखिए ये रहेगा 4 3 12, ठीक है, 0 0, 4 से कर रहे हैं तो -3/2, फिर -3/2 और लास्ट वैल्यू बन जाएगी 1, ठीक है। ऊपर चलते हैं, 1/8 है, तो इसको करने में तो मेरा R1 माइनस 1/8 R2, 5/2 था, 5/2 माइनस 1/8 × 12, ठीक है, 8 कर लेते हैं, तो 4 5 20 -12, 8/8 1, ये रहेगा 1, ये है 0, ये रहेगा 1, ये है माइनस 1/8, ये रहेगा माइनस, नहीं सॉरी, +1/2, ये हो जाएगा 0। थर्ड वाले पे आते हैं, R3 प्लस 1/4 R2, इसमें ऐड करना सीधा सीधा, तो 1/4 कर देते हैं, तो 1 + 3 4 हो जाएगा ना, ठीक है। तो पहली वैल्यू हो जाएगी 1 रहेगी, ये 0 ही रहेगी, 0 है, तो ये -1/2, 1/8 -1/4 हो जाएगा, ये 0 हो जाएगा, ठीक है। तो लेट्स चेक z, z हो गया कितना, 3 + 20 23, जेड से देखते हैं, जेड से देखिए यहाँ पे है, ये तो 0 है, बीच वाला 0 हो जाएगा, यहाँ पे 5 हो जाएगा, यहाँ 3 हो जाएगा, ये हो जाएगा 3/2 और -5/4, 3/2 -5/4, 6 -5/4 1/4, सॉरी ये -1/4 नहीं, 1/2, हाँ ठीक है, -1/2, तो ये हो जाएगा 3/2 -5/2 -2/2, ये -1 हो गया, ये हो जाएगा 0। तो अब CJ - ZJ करते हैं, 0 0, दिस इज +1, so all the values are positive, ठीक है, so this is the optimal, since all CJ - ZJ are positive, so these are positive, this is reverse from the case of maximization, ठीक है, तो जैसे नहीं फर्क है, तो ये सारी की सारी पॉजिटिव हो गई है, इसलिए मिनिमम z is equal to 23 and x1 is equal to 4 and x2 is equal to 1, okay? So that will be the first type that we have, okay.